All right, hey, let's talk about MPLab. So MPLab is the IDE you're going to be using for Engineering 270. And the first thing you want to do is download it. And it's very important that you download the correct version, which is version 5.1. It's not the newest version. The newer versions don't let you do the things that we're trying to do in this course. So if you follow the link on Lab 1 under Preparation, where it says install version 5.1 from the following link, that link will take you to this page. And if you scroll down, you'll see a number of different versions. And right now, it's on page 7 where we can find version 5.1. So download the version for either Windows, Mac OS, or Linux. Go ahead and if you download that for Linux, you'll get a tar file. And if you download it for other versions, you get something different. But go ahead and download that and run the installer. So I've already done the download. And for Linux, the way I install is I say sudo sh and then the name of the file, mplab 5.1 linux installer.sh. Sudo lets me run it as root. And this should be basically the same setup regardless of your operating system once you start the installer. So we'll do some initial checking, uncompress the library, and then it'll go through sort of the standard wizard that takes you through setup instructions. And let me just show you some options you can click here. So go ahead and say next, accept the license agreement. You can go ahead and take the default installation directory. We don't need MPLab IPE, we only need the IDE. It's up to you whether you want to consent to anonymous usage information. But definitely we want MPLab X IDE, that's the tool that we're going to be using. Go ahead and say next. It's a pretty fast install. And then a couple of other options we're going to want to choose from in a minute. Now, if you're not working on your own machine, if you're going to be using the machines in the Collaboratorium, my suggestion is, take this installer, put it on a flash drive, and then log into the machine in the Collaboratorium. It'll be a Windows machine. Just pop in your flash drive, copy the installer over, and go ahead and run the install. It'll take a few minutes, but if you're going to sit down and spend a few hours working on your 270 homework or labs, you do this once and you're good to go until the next time. So this is just telling you about USB communication. Go ahead and say OK, and there'll be another information pop up, and just go ahead and say OK. And pretty much we're just taking all the defaults. Now this page is saying that it will offer to open up a web browser and show you additional information. If we don't want to see that, just uncheck these and say finish, and we should be all set. So at this point I've got MPLab X installed, so I can go to my application finder and just search for MPLab. And I don't need this terminal window. Now if you do this on your own machine, you obviously only have to do that setup one time. But again, if you're doing this on a borrowed machine like in the Collaboratorium, be prepared to do this install each time. Alright, so we always open up with a marketing page called the Start page. You can close that out. If you've been working on projects, you'll see your projects over here, but since we're running with a fresh installation, this area over here is empty. So let's go ahead and just make a first project, and this is what I'm asking you to do in question 5 of that first problem set, is create this very simple program. So here's the steps we're going to follow. File, new project, and leave this as is, microchip embedded standalone, say next. Now we need to tell it what kind of processor we're going to use, so I'm just going to type in pick 18F1220 and then say next. And then our tool is going to be a simulator. If we were actually programming a chip, we would pick a PIC-Kit 3 or PIC-Kit 4, but we're just simulating the physical device. So say simulator, next. and then we want to use MPASM, right? So that lets us do assembly language programming, and say next, and then we get to pick a project name. And I'm going to just take the default location for projects, and for my project name, I don't know, I'll call this Lecture 1C Demo. Doesn't have to be anything that fancy. And say finish. Now every project I do wants to be in its own project, right? So don't do all of your different labs and homeworks and practice problems in one project. Make a new project every time you're going to make a new piece of code. So Lecture 1C Demo. Alright, got a sus message down here, but I'm on a weird setup. So let's make a simple assembly language program. So I'm going to right click on the project name Lecture 1C Demo, and I'm going to say new, and I'm going to say new assembly file.asm. If you don't see that, go ahead and click other, come down here to assembler and choose assembly file.asm. And then the next time that you say new, it'll pop up as the first option. Alright, file name, we can call this whatever we want. I'm just going to call this main.asm. I'm just going to call it main, and it'll add the .asm. Going to leave the default folder, default project, all of that, and say finish. Alright, I've got an empty file with 4 lines of empty space. Let's make an assembly language program. So I'm going to say include quote p18f1220.inc. Okay, this is pulling in information from a file, an include file, that sets up a bunch of useful symbols for me. Alright, so this is going to be a really short program. I'm going to use that include file, and then I'm going to say org 0x00. That says, hey, I want to take this code I'm about to write, and I want to start storing it at location 0 in program memory. We're going to go through all the details of this much more carefully in the coming classes and lectures and practice problems, but this is just to kind of get you on the air quickly. Alright, so now we're going to say increment file register 0x00, and I'm going to say branch to loop, and up here in the beginning I'm going to put another statement, loop, right in column 1, and then I'm going to just say end. So a 7-line program. And you know, we can put comments in here also, and we're going to want to get in the habit of putting in comments, and comments are things that begin with a semicolon. So sample program for lecture 1C. Alright, so there's, you know, just some comments in the beginning. Alright, let's see what this program does. So I'm going to hit this hammer signal to say go ahead and build the project. And it will try to build it, and it will say build failed. Okay, so when you see that, what you want to do is you want to scroll up in this window and find the first error message. And the first error message I found was cannot open file p18f1220.inc. So I'm going to change the name to be uppercase, and I'm going to hit the build button again, and it still did not find it. So let me try this. Alright, so put it inside double quotes and make it lowercase. So this is going to be the general process of writing code, right? You're going to write your code and then try to build it. And if something goes wrong, you're going to scroll up, find the first error message. In this case, it says line 8, symbol not previously defined, LOP. And I can look there and say, oh yeah, I had a typo. I should have had LOOP. And try to build it again. You're going to keep doing that until it builds successfully. This is getting your program to compile, like in 121. Alright, this tells us we've got good code here. And so now we want to execute it. Well, we're going to run it in the debugger. So I can debug it by hitting this button, but that's not very satisfying. It tells me the program's running, but I have no idea what it's doing. Alright, so here's what we're going to do. We're going to hit this stop button, and I'm just going to click over here and put a little red square here. So if I left click on a line, it will put a red square. If I click again, it goes away. That's called a breakpoint. That says that when we run our program, each time it gets to this line, it's going to stop. So it's telling me, hey, program hit a breakpoint at line 7, which is right here. And I can see some information. I can see what my program counter is. That's where I am in the instruction. I can see my flags and so on. Now I can hit this button or an F7 and say, hey, execute one more instruction. So if I hit that, it moves down to the branch instruction. That little green arrow says I'm about to execute the branch. My program counter is equal to 2. That's the address where this branch is stored. And if I say go ahead and step again, it'll go back to line 0. Alright, so what is it actually doing? Let's go over to Window, and let's go to Target Memory Views, and let's look at file registers. So when we say INCF, that means increment file register 0. So let's go ahead and run this program, and I'll go back to my file registers, and you can see that file register 0, that's this one in the upper left, is equal to a 0. Now if I execute this increment instruction, that file register changes to a 1. And if I step once more, it'll go back to line 7, which will say increment file register 0, and after that increment, this register is now equal to 2. And every time it changes, it turns red, so we can see that it just changed. So if I keep stepping through, we can see that this file register down here is incrementing once each time that we say INCF. Right? So that's exactly what it should be doing. Now if I take off the breakpoint and I say continue, and then I say pause, right, my file register is equal to EC. If I run it some more and say pause, it's equal to 3A. So if I just do this without a breakpoint, it's running as quickly as it can. But if I put a breakpoint in there, then every time it gets to that instruction, it pauses, lets me look at my variables, lets me type instructions, or say, you know, go ahead and continue. So now I'm counting up by ones. So that's kind of a hello world for PIC assembly language. Several lines of code that just, you know, keep incrementing. And this window, by the way, is not usually how we're going to look at file registers. We can also go to this variables window and we can look at registers there, and the labs will take you through the steps for doing that. But this is enough of a demo to guarantee that you've got MPLAB installed. You can write assembly language, you can assemble it, you can execute it, you can step through it, and so on and so forth. So that's your last homework problem for today.